Hello and welcome to another revision video. Today we're looking at the Foundation Tier Revision Workbook from Edexcel, and we're doing a bit of problem solving practice for geometry and measures. Okay, so question one, BEG and CFG are straight lines, so we've got our straight lines. ABC is parallel to ABC and DEF are parallel. Angle BEF is 48. Angle BCF is 30 degrees. So I'm just trying to read that and visualize it in the diagram as well. Work out the size of the angle marked with the X. Give a reason for each step of your working. Okay, so I'm going to zoom in nice and large on this just to show you in a bit more detail. So you've got a few ways that you could do this. You could work out this angle by saying it's a supplementary angle to this angle here. Or I'm going to take a slight shortcut. Probably I'm going to say this angle here. So GEF is going to be equal to 180 right particularly well. So 132. And the reason for that is that angles in a straight line. On a line equal 180 degrees, and then I'm going to say that this angle here, EFG is going to be equal to 30 degrees, and the reason is that it is a corresponding angle to BCF. And then from there, I'm going to use angles in a triangle. So I'm going to say that X is going to be equal to 180 minus 30 plus 132. I'll put that in brackets. So it's going to be equal to 180 minus 162, which is going to give me 18 degrees. And the reason for that is angles in the triangle, equal 180 degrees. Right, I'll zoom out now, and I'll put my answer on the answer line, 18 degrees. Okay, question 2. A rectangular tray has a length of 60 centimeters, a width of 40 centimeters, and a depth of 2 centimeters. It is full of water. Water is poured into an empty cylinder of diameter 18 centimeters and height of 20 centimeters. Will there be any water left in the rectangular tray? You must show your working. Right, I think I'm going to need a calculator for this to do it exact, but we'll do that in a moment. So I'm going to work out the total volume of the tray. So the volume of the tray I'm going to call VT, and that's going to be 60 times by 40 times 6 times 4 is 24. 24 times by 2 is 48 with 2 zeros. So that's my volume. Now I need to work out the volume of the cylinder, and this is where I think I'm going to need a calculator. So the volume of the cylinder is going to be the area of the circle, so pi r squared, times by the height. So in this case, it's going to be pi times by the radius is going to be 9 squared times by the height, which is 20. So that's going to be pi times by 81 times by 2 is 162. So let me just double check that. Yeah, 162. So 162 pi. I missed a zero off there, sorry. So that's going to be 162 1620 pi. Right, so let's bring my calculator in then. So, and I've double checked all of my workings as well at this point. 60 times by 40 times by 2 is 4,800. Yeah, we were right there. Right, my calculator will give me this in terms of pi as well. So times by 9 squared times by 20 is 1,620 pi. Okay, so that as a decimal would be so let me just adjust my right. Just had to adjust that because as soon as I tapped on my screen, my calculator would have disappeared, so that it would be 5,089.380. So I'm going to go dot dot dot. So will there be any water left in the rectangular tray? No, as 4,800 is less than, let's go centimeters cubed, is less than 5,089.4 centimeters cubed. Okay, and question 3. I don't think we need a calculator for this, so let's get rid of that and make this a little bit bigger. Wrong way. Okay, transformation A is a reflection in the line y is equal to minus x. Transformation B is a rotation of 180 degrees about the origin. Alison draws a shape and labels it P. She carries out the transformation A, then labels it Q. She then carries out the transformation Q and labels it B. She labels her final image R. Describe the single transformation that will map her shape P onto R. So if we think about it first of all, okay, so I've just brought this into a different program just so I can bring a ruler in. So if I just kind of map out the two transformations, and then we can kind of think about what the resultant effect would be. Okay, interesting. It's not drawn particularly accurate, so I want, let's just put the points that I want to draw on. So I want it to go through 6, 6. Let's go 2, 2, 0, 0, 2, 2, 2 minus 2, and then 6. Okay, slightly interestingly, this actually isn't drawn correctly. This line, because if we look, okay, 0, because we've got 2, 2 here, we've got this line drawn here, and there's actually a gap of 3, and then 2, and then 2. So this isn't actually drawn accurately. Okay, so that point should be there, that point should be there. So the scale of the graph is actually slightly out. It doesn't, provided we've spotted it, it's not a massive issue. So let's say that's going to be our line of y is equal to minus x. I'm going to put the axes incorrectly. Let's do this in black. So that's the axis. My line's slightly out, but I'm sure you can get the idea. Right, so if we imagined any shape, so I think this is going to be a reflection in the line y is equal to x, but let's kind of justify it. So if we imagine that this was the shape that she drew, for example, and I'm going to, I want a slightly irregular shape, just to show my point. So if you imagine that's our shape, if we reflected that in that line first of all, let's label it Alison draws a shape, she labels it P, let's pretend we're Alison. She carries out transformation A, which is the reflection in this line. So that would take this point to here, this point to labels it Q, and then do the rotation of 180 degrees about the origin. So 180 degrees would take us to slightly interesting. I'll do this in a different colour just because I'm actually going to overlap my shape, which I probably shouldn't have done, but that's fine. So if we think about where would that move, so that point alone would, let's start with that one. So that point would go to there. Let's think about that one. That would go to there. There we go. So the resultant effect, if you think about this shape, we've got a reflection in the line y is equal to x, which is what I thought. Right. Let me go back to my book then. There we go. So the result would be a reflection in the line y is equal to x. And that will work for any shape. You didn't need to pick the one that I did. That will work for any shape. Okay, that brings us to the end of this. So again, this was Geometry and Measures Problem Solving section or page 113 from the Foundation Tier Revision Workbook. Any questions, comments or feedback, please type them into the thread for this video. Thank you for watching and subscribe if you like.